One of the links in the chain of how blockchain works is the devices that we use on the edge of the network, our phones, our PCs, even our automobiles and other devices. And that poses some problems for security. And so that is exactly what our next speaker is going to address. Len Veil from Rivetz Corporation is going to talk about device security in blockchain transactions. Please give it up for Len.
Thank you. Thanks, everyone. So the title of my talk today is Provable Device Security in Blockchain Transactions. A lot of words, but we're trying to address is the edge, the endpoint, to ensure that we've got adequate protection in the entire transaction that occurs within blockchain domains. So when I first started working at Rivetz, had a nice chat with our vice chair, and he said something interesting to me. He said the most valuable data that we have today is no longer at the NSA, it's in your pocket. And I think it's a really interesting observation that all of the information that used to be hosted in the cloud, not all of it, but a lot of the information that used to be hosted in the cloud is now migrating under our own control. It's ending up in our pockets, and it's now our responsibility to ensure that it's adequately protected. So what we're seeing today is these assets moving from the cloud down into your pocket because we're transitioning from an environment where you authenticated to a cloud service and then ran the applications in the cloud to an environment where you're interacting directly with the blockchain. So those digital assets are now ending up under our control so that we have to appropriately manage them. What do we mean by digital assets? Well, everybody's familiar with Bitcoin and Ethereum, Ether, and the keys that are used to manage those cryptocurrencies. But there's a lot of other digital pieces of information that are ending up in our pockets that we're going to need to adequately secure as we go into the next generation of applications and infrastructure. So some of those are, for example, 2FA codes, the codes we use for the algorithms to interact with 2FA authenticators. Financial account credentials, how are we going to move our account information as the traditional financial providers move onto the blockchain. Healthcare, so interesting, 56% of healthcare executives anticipate having blockchain applications by 2020. The users are going to have to be able to interact with those chains to see their health records, to see what test results, to just update information about their person. So we see a lot of examples, identity. So the recent work that in the Decentralized Identity Foundation, and there's my last count, there was over 25 companies doing identity services on the blockchain. We as individuals are going to be interacting with that. We need to make sure that the credentials that we use are going to be appropriately protected. Fortunately, there's been a great amount of fantastic work and innovation done in the blockchain, and that continues to occur. So the blockchain itself is inherently trusted through its design. There is no central entity that you need to trust. It's built upon this mechanism of rewards and incentives and consensus. And we have really good capabilities, really good trust and security capabilities out of the infrastructure. So as that occurs, we also need to recognize that there are a variety of applications where we desire anonymity, like cryptocurrency, and then there's a variety of applications where we're going to require non-anonymous transactions. And so those might be in supply chain management, where you're moving assets through the corporation or across corporations. So a lot of examples that we can think of interacting with your healthcare provider, for example. You're going to want to know a lot about the edge device. You're going to want to know a lot about the edge user. and we're going to want to be able to audit this information in these application spaces. So the blockchain has really given us a lot of trust, a lot of inherent security, but when we interact with that, we do that through keys, and we need to bring that same equivalent capability, that same equivalent security down into our pockets, into our edge devices. So who has the key? Well, the first thing you do when you set up an HDW wallet is export the key. And the way you export that key is by writing down those 12 or 24 words. And from that point on, you have no clue, no idea where your wallet might go. Because in 2 years, every house cleaning service and every service appliance repair person is going to be walking through your house looking for that yellow sticky that's got 12 or 24 words on it. And once they find that, that's going to be the last house they ever clean or the last appliance that they ever repair. So we really, really need to get control of our assets. Additionally, we need to understand the quality of the applications that are managing our assets. So I did a count the other evening. There were more than 75 wallet vendors on the Google Play Store. A lot of those are highly reputable companies that you see here in the hallways. Some of them not so reputable. Some of them are capturing your keys and at some point might do something with that. So it's really important that as we go forward and we begin to interact with the blockchain on a much more frequent basis, that we have an understanding of our keys and where were they created and where are they going. The other thing that we tend to do is we tend to key off of device identity based upon things like your MAC address or your IP address. Take your same laptop and go to a different location, different network, and try to interact with an exchange, and the exchange thinks you're on a different machine. In reality, you're not. And why are they doing that? Because your IP address has changed, so they need to go figure out whether they're going to trust you. On the other side, we really have the technology today on our desktops and in our pockets to get strong machine identity, strong device identity, and to use that in a non-reputable, non-spoofable fashion to prove that the device that you're interacting with an application is the same device that you previously interacted with, no matter where that might be occurring. So there are opportunities to increase the integrity of the device information, the device identity that we're interacting with. So a couple of the challenges that that I just described have been addressed in the enterprise world. We've got about 25 years of trusted computing development, research, product deployment that we have worked through for the enterprise that solves a lot of these problems. And it's time today to bring some of that technology and to deploy it against blockchain applications to ensure that we've got good transactional integrity across the whole ecosystem. So from trusted computing, what we find is that we can have strong device identities, which can be rooted in hardware. You have to desolder a device usually to change that. We have isolated execution environments, these environments where we can run operations, compute operations, and guarantee that those compute operations aren't observable. So an environment where we can operate on our assets. We have the ability to securely store these assets on a platform to ensure that those assets can only be available on a particular platform. We can also verify that those assets are being operated on in an environment that they previously were operated upon. In other words, that the platform hasn't changed significantly, malware, for example, hasn't been introduced. So a lot of the trusted computing principles from the past couple decades can be applied to help solving some of these problems. Interestingly enough, I look at several thousand or 1,000 people here today, and it kind of reminds me of the early days of device security, the early days of platform security, when with the advent of the RSA conference, I was fortunate enough to attend the third RSA conference, which was about 300 people. This year, RSA will host about 45,000 people. So the point is that industry has really, really grown up. This industry is on a similar growth curve, and we need to take some of the technologies out of trusted computing space and bring them into the blockchain world. One of the technologies is what we call trusted execution, or trusted execution environments, and this was standardized in an organization called Global Platform, which is where your smart card technologies for credit cards, things of that nature have come out of. So the trusted execution environment is an environment where you can run all these operations and you can't observe it. There's no way to run debuggers on it. There's no way to take that device and shove it in a freezer and have it stop and then go inspect its memory. Execution in a non-observable fashion. And so this gives us the capability to do a bunch of interesting things that we normally wouldn't be able to do if that execution thread were able to be watched. For example, to protect keys. For example, to place policy on those keys, on those digital assets, to ensure they can only be used in certain ways. So the trusted execution environment, one of the key technologies that we need to take advantage of in protecting our digital assets. By the way, that trusted execution environment is probably in your pocket today. It's on over 700 million devices. It ships natively on many Android devices and iOS devices. It's just not being taken advantage of to its full capabilities. So that's one of the things that we Rivetz are providing, is the access to trusted services within these trusted execution environments. And by the way, that similar technology shows up on your desktop in the form of SGX and Intel technology, and it also shows up in cloud services in the form of HSMs, hardware security modules, and it shows up in smart cards, credit cards in the form of secure elements. So a lot of this technology is available, has been proven out, and we're going to help bring it to the blockchain. So we talked about keys a little bit, and I wanted to actually dive into a couple things in the security space about key types. Generally, we have three different kinds of key types that we manage in trust computing world. There are non-migratable keys. You create these keys in a secure environment. You can ever get them out. You cannot ever get them out. And so not very applicable for things like cryptocurrency wallets, for example, where you want to be able to back up. Then we have other key type we call migratable key. And a migratable key is something that you can create in a secure environment and then export, and it can go wherever it wants to go, and you don't track it. And it has value in certain applications. But the most interesting one in the blockchain space, at least to me and Rivetz, are what we call certified migratable keys. These are keys that when they are created, they carry policy with them, and then we can determine when these keys are exported out of an environment and put into a new environment, and we can provably move them and we can provably destroy them. So from a, for example, crypto wallet perspective, incredibly valuable technology to ensure the integrity of the transactions. Spoke about roots of trust. So somewhat obscure terminology for something that's soldered to your motherboard, or soldered to your inside your phone, or soldered inside your car or your television. A root of trust is a device that you can place in the compute environment that repeatedly and reliably runs all of the code that you've asked it to run. So generally, if you think about a PC, for those that know a little bit about PC architecture, We put roots of trust in the BIOS because they're not changed, and then we can ensure that that is going to run that same code every time in a repeatable fashion. Those are generally immune to most physical attacks, other than somebody, for example, desoldering your device and soldering a new one on. But that doesn't occur really in most consumer worlds. The root of trust gives us a bunch of security services that we can use to measure and assert the integrity of our platform. So as an example, this is what we call transitive trust, which is a root of trust measuring a set of services and then having that measured set of services recorded into the environment so that we can now provably assert to a third party the characteristics of that environment. In this example, power on self-test and then boot the machine. And during the boot process, you actually verify the extended ROM or extended flash capabilities. And once you've done that, then you can use code in the extended root of trust to do additional measurements of things that exist outside of that instantiated root of trust, the initial root of trust. So in this example, I show us verifying some cryptographic modules that might be elliptic curve that's used for your Bitcoin wallet. It might be hardware random number generation that's used to create your seeds and your keys. And we also can use that to verify trusted execution environments, whatever form that might be. As we go through those measurement process, we also record that information so that we can use that in future operations. Real briefly, one of the other capabilities that we have in these devices is what we call security domains, and it allows for multi-tenancy. The ability for service providers, multiple service providers, to exist in a device to grant services to a device or its users, but also to ensure that its secrets, its digital assets, the ones that it shares with the user, could never be observable or visible by another application or another security domain. So whether it's a device that I have where I have my personal information and also my enterprise information, one example. Another one might be a device that's shared amongst the family where mom, dad, Alice, and Bob can have different access credentials, different capabilities, different keys, different digital assets that they manage. So security domains are an important part of the ability to protect these environments. So when we have a trusted execution environment, we now have somewhere where we can apply constraints to ensure that those constraints or policies are actually followed upon. So the trusted execution environment gives us a way to ensure that the code that we're executing on these keys, the policy that we're applying on these keys, can be determined in a trustworthy fashion. So a couple examples of policy on keys. So did my platform change since I last did a transaction? So I might want a specific browser version, for example, or disallow a specific browser that's known to have security issues. If I'm doing a cryptocurrency or blockchain transaction, is this a address that I am allowed to transact with? Is it on my whitelist? We can even look for third-party oracles, third-party services to be able to tunnel down into that trusted execution environment and give us red light, green light. Yes, you are in an environment or you are in a posture where you're allowed to do a transaction. For example, geolocation, if you were doing gambling, am I in a legal gambling area? A third party might make that determination and securely authorize me to do that. We also talk about collections of devices. the ability, for example, to replicate my wallet key across multiple devices that I use on a daily basis. But I also might want to know that I physically am in range close to a machine that's doing a particular transaction. For example, I'm moving $50,000 of Bitcoin on the blockchain. I'd like to know it's really me, or have a good feeling that it's really me. Well, I never go anywhere without my phone, and very few people I know ever go anywhere without their phone. You could, for example, say, is my Bluetooth device, my master device, within 25 feet of my main device? So that gives me some physical proximity. Examples of policy that we can lay on some of these applications, some of these keys. One of the other things that we need to do is we need to make sure that we're using certified implementations. So every credit card that you have in your pockets, the smart card chips, for example, those have been certified for the hardware to make sure that they're running the cryptographic algorithms correctly. And they've also been certified by the card associations that they're running the application, the payment application correctly. So these are not inexpensive propositions to go get these applications certified, but they bring an incredible amount of integrity to the applications and to the environments. So one of the things that we need to start doing is looking at certified containers for the keys that we use to interact with a blockchain. So when we have all of this information, using the root of trust, using trusted execution, different key types, what can we do with it? Not only can we enforce some of these policies, not only can we have a much better feeling about the quality and safety of the transactions that we're performing, but also for those transactions where anonymity is not required, matter of fact, where it's not preferred, we can take all of that information and record it on the blockchain along with the transaction. So, for example, I'm purchasing a house, and you want to know what device, what location, information like that we can record, on the blockchain along with the transaction. So, as we bring trust into the environment, into the edge device, it allows us to fundamentally change the way we interact, we as users interact with the world. For example, we could get rid of username, password, 2FA when you're dealing with exchanges. Why? Because you authenticate to this device, and then the exchange could be 100% certain it's this device using strong device identity. My fingerprint tells this device to participate in a transaction with an exchange. The exchange knows exactly the device that it's interacting with. It's got a history of that. It's been registered. It's been approved for those transactions. One example of the ability to use strong device identity. For crypto wallets, for example, we now have the ability to create HDW wallets, but not have to export that 12 or 24 word list. Instead, take that seed, take that master key, appropriately archive it into the environment that you feel comfortable with. That might be another device of yours, that might be an attorney, it might be a third-party escrow service, it might be a smart contract on a blockchain. But we can get rid of that leaking of that key, the exposing of that key is the first action that we do by bringing some of these capabilities into the environment. And certainly this allows us to provably move keys throughout the ecosystem and do things like enforcing multi-sig contracts, multi-sig transactions. So we get assured transactions by knowing the user, having a known user on a known device in a known condition. Critically important to the characteristics of the Rivetz network. So the Rivetz network is the mechanism to deliver provable cybersecurity controls to edge devices. We protect digital assets. We allow policy to be placed on those digital assets. We provide mechanisms to attest and record the integrity and quality of the environment in which these transactions are being created and executed. And we also allow the user to create and manage their collection of devices and their digital assets within that ecosystem, within that domain. So I think I will end with 58 seconds left, and if you guys have any more questions, come visit us at booth 27. Thanks. No.
We're taking a short break, 10-minute break, and we will begin again in 10 minutes, I think at 12:25.